Welcome back, everybody, to Between Bells. Alzheimer's is a disease of the brain that causes the brain to shrink due to a buildup of abnormal proteins. Now, the disease is the 6th leading cause of death here in the U.S., and for decades, scientists have been looking for a treatment, and now an injection to halt the progress of Alzheimer's might be available within the next decade, which would be amazing. Joining us now to discuss is Dr. Campbell, cardiologist and CEO over at Pacemate. Dr. Campbell, great to have you here. Thanks so much for joining us. So for those that don't know, explain maybe Alzheimer's and their impact on the body and brain, because it's no doubt we probably had a friend or a loved one who suffered from this.
Absolutely. So Alzheimer's is the most common form of dementia in the world. And as you mentioned, there's almost 18 million Americans who have Alzheimer's now. One person is diagnosed every 63 seconds with Alzheimer's. Right now, there is no cure. We do have medicines that can halt progression. We have medicines that can lessen symptoms, but ultimately there's no cure. Alzheimer's can affect memory, it can affect cognition, it can affect your behavior, you can become combative, you can become disoriented or confused. So it's a terrible, terrible disease, and it's all related to deposits of a particular protein called amyloid in the brain.
So it sounds like we have some optimistic news now, at least with this injection. So what is that injection able to do that wasn't done before?
So most of the drugs that are being developed now actually target that protein in the brain and have that protein removed from the body. And there's some promising drugs. One is made by Biogen IDEC that was just presented in October of last year. Now this new injection actually is a way to manipulate the genes or your DNA, and it can actually turn off the genes that make amyloid. So it's actually starting in the process a little bit earlier than after the amyloid is deposited. The only caveat here is this particular injection only works in patients who have a genetic form of Alzheimer's, which is a small subset of patients.
Oh, interesting. So it only works for the small subset, so it wouldn't be working for those that probably have it now as well. Explain the scientific breakthroughs and how we got to this particular moment right now.
You know, I think it's very interesting. We were studying patients that had a childhood neurologic disease, a muscular atrophy disease, which can lead to paralysis, to where you're on a ventilator, almost like Lou Gehrig's disease in a way. And they actually started manipulating the genes in these children who had that gene and actually were able to prevent progression of the disease. So when they saw this, they thought, maybe this is a way that we can turn on and off the genes that make amyloid in patients who are apt to develop Alzheimer's disease. And so that's how they started down this pathway. It really argues for sharing data and sharing scientific knowledge among different companies, among different disease states, so that we can, develop better drugs for more people much faster.
So we're seeing developments in preventing the progression of the disease, but what research and what medicine do we have to be preventative from the very beginning? Does that exist right now?
It really doesn't right now. What we know is if we can diagnose Alzheimer's dementia early, we can start intervening early and halt progression, and slow things down, such as, there's behavioral therapies, there's putting patients who have Alzheimer's in the right environment where they're not challenged to remember things, where you have patterns of set daily routines. Also, these medicines like Aricept and some others can actually prevent the progression to a certain extent. Ultimately, it progresses, it's not a cure. And then Biogen developed a very interesting drug that was just presented last year that actually has promise of removing that protein from the brain. And in the study that they did, almost 90% of the patients saw an increase or an improvement in their cognitive ability.
What sort of potential drawbacks or maybe some negatives are also associated with this that maybe they're working on right now as to why we're not going to have this drug out for another 10 years?
Well, whenever you start manipulating DNA and doing gene therapies and things like that, there's a lot of ethical concerns, just as we all heard about the cloning experiments that have occurred in China and the controversies surrounding that. So I think there's a lot of different factors to consider when you start manipulating genes. But however, I would argue that we need to do whatever it takes to cure these once incurable diseases, like Alzheimer's, like Parkinson's disease, like all these other diseases that just have such an awful impact on not only the patient but the family. And I think if we explore these, but explore these with a responsible eye, I think that they are acceptable ways to move forward.
To that point, though, how applicable is some of this research around Alzheimer's to other diseases? Could this injection or the technology behind it be used for other diseases?
I think it absolutely can. I think we're starting to see genetic manipulation of disease processes to become, a real focus for research in many, many different areas. I'm a cardiologist, and even in cardiovascular disease, we're looking at ways to prevent cardiovascular disease when we can identify patients at significant risk by potentially manipulating the way cholesterol is produced in the body or manipulating the way heart disease and inflammation occurs in the heart artery. So I think that it can be applied in many, many different areas, and I think as soon as we continue to do these research projects, get more funding towards these ends, I think we're going to see massive strides in the next decade.
You mentioned funding. On a high level, how much focus and funding is there on Alzheimer's? As we mentioned, the 6th leading cause of death here in the U.S. How much funding is there for this?
I think there can never be enough. I think there is significant funding and research going on at lots of academic institutions. There's lots of federally funded grants, NIH grants, things like that are funding research in this area. I think the drawback is you see in a lot of companies that are starting to put some money in there but haven't really fully committed because right now it's not profitable for these companies. I was really glad to see my friends at Biogen come up with this new drug because I think that this is going to really change the game potentially, and then this drug that we talked about today from the UK also has the potential to be a real game changer.
How close does this put us on, Doctor, to a full-on cure of this particular disease?
I have what I call cautious optimism. I think that the science behind this is solid. I think that the developments are moving forward, but I do think you're talking a decade until we can get this to where we can actually cure a disease. Just like other diseases, like you think of diabetes, type 1 diabetes that's insulin dependent. We've been struggling to cure that disease for many decades, and we're still not there yet, but I truly believe within the next decade we are going to have a cure for that as well.
You had mentioned profitability as well. I'm curious, how much does the monetary bottom line and profitability for these companies, whether it's pharma companies or research organizations, how does that drive which diseases actually get the focus and the money and the funding at the end of the day?
Well, when you think about it, if it's a very, very rare disease like some of these genetic disorders are, and it's a boutique drug where you've got a very small population of potential users of your drug, they don't put a lot of money and time into that, and you have these boutique companies that do work in that area. When you have a big company like J&J or like Pfizer or any of the big pharmaceutical companies, they're going to make drugs that impact their bottom line, which are going to be drugs that treat common diseases that are widespread: hypertension, diabetes, heart disease, things of that sort. So I think there is an inequity in the ability to do research in a lot of these areas. You don't have as many hands stirring the pot, and that's a drawback.
Well, caveats included, this still sounds like incredible news. Dr. Kevin Campbell, cardiologist and CEO of Pacemate, thanks so much for joining us and giving us the good word on this.
Thanks for having me. Happy New Year.
Happy New Year.
And coming up, everybody, on Between Bells, Tiffany.